Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video, we're going to take a look at a case study for one of my clients. Hope you enjoy it.
Okay, welcome to the latest case study, and as you can see, the title of this little presentation is going to be the power of reducing variability. So this is a case study. I'm not going to show you all the technicalities of the case study, but I want to show you exactly what that title says, the power of reducing variation. Six Sigma, sometimes you read about Six Sigma and it says, oh, it's about variability and removing variability. And people sort of shrug their shoulders as if to say, yeah, okay, so what? What does the power of reducing variation give me? Well, I'm going to show you this in this particular case study. So let's get into this. So I've taken away the company name, by the way, so just to keep their details a little bit secret. But essentially, look, what are we trying to do? Well, we're looking at OEE. So they have a machine. It's some kind of automatic machine, and what they're doing is they are doing a refurbishment. They are refurbing. And it's printer cartridges. So they refurb printer cartridges. So they take an empty cartridge, they take the cartridge to pieces, put fresh ink in it, and then sell it as a refurbished unit. So that's what they do. And the machine that they have is taking the cartridge apart. So that's its main job. So it's an automated machine. You put the old cartridge in, and it takes the thing to pieces for you. And the OEE is particularly poor. Lots of machine losses, etc. So the project is all about improving the OEE of that particular machine. So let's take a look at the current performance. So here we are, January to September 2017. We've got the OEE look at the top. So here's the current performance, and you can see look at the variability in that. So I think it summarizes up what the current performance is. So current performance, look, 41%. But the key point for me is look at the amount of variability in this thing. Look at the way it's just flying around anywhere between 65% and 5%, essentially. It's just flying around everywhere. And of course, the danger is that what you keep thinking, if you're not trying to tackle variability, but you're just trying to make it hit a good position, this particular week, you'll have a party because you've hit a good point. And then, of course, because you haven't really got it under control, whoops, and it goes back down there. And now, well, we better do something about that. And it's the variability we want you to control. Now, obviously, they've split the OEE correctly into the three categories. So what have we got? Availability, we got productivity, we've got quality. And by the way, you should look at them in that order. Availability first, then productivity, then quality. And again, if you look at the performance of each one of these graphs, here's the point. Look at the variability. And this is a key point. This is the way I would always be looking at a process. I teach my customers, my clients, your processes are in three states. They're in a state of chaos. They are in a state of control. They are in a state of excellence. The first thing you must do is take the process from chaos to control. And right now, variability is a measure of chaos. Look at the availability performance down here. Look at it. Look how chaotic it is. You come to work each day and you have no idea what's going to happen. No idea whatsoever. and it could be brilliant. In this case, look, 100%. Could be as awful as 20 odd percent. You have no idea what's going to happen. That is a chaotic environment in which to work. As is the productivity, as is the quality. So we are going to go from chaos to control to excellence. And you're going to see those 3 steps in this particular project. So she set the target, just before I come off there, she set the target, look, of OEE of 80%. And she's sort of suggesting that it's a dream target, because obviously to go from 40 to 80 does seem like a dream target. That's an incredible change in performance for this piece of equipment. So then she starts looking at the various problems, repairs in the last 10 days, availability, and she's kind of looking at availability and quality together, because what tends to happen is when they tend to get problems, so when the machine is not performing its task correctly, they get quality problems. And of course, what then happens is they shut the machine down to repair it, and that gives them availability problems. So these two are very much linked together. And look what she does. Look what she does. Now, this is really important. What she's doing here with each failure mode. So here's the failure mode. Toner cap not removed, screw not fitted, gear holder not fitted. So here's the failure modes. What she's done, look, she's driven the variability out of these graphs, and that's very important. Of course, what you're seeing is the fact that the performance has gone from terrible to fantastic. That's what you're looking at on the graph. But that wasn't the way she tackled the problem. The way she tackled the problem was to simply say, how do I get the variability out of this graph? And if you take the variability out of this one, for instance, is lower, the better. All of these graphs actually are lower, the better. If you take the variability out of a lower, the better, or indeed a higher, the better, the process will just go to the good place. It will go to the target you're trying to hit. You cannot be consistently crap at something. And here's the graphs that prove it. What she tried to do was remove variability. And by doing that, she's driven the process to a great location. So let's have a look through. Look, all of these. Look, screw outer. Look at this. Look at the chaos here. What she's done is removed the chaos, driven it to a good place. Look at the chaos here. You notice it doesn't consistently. You don't get consistent rubbish performance and then consistent good performance. That's not what's happening. What you get is chaos, then control. And when you go to control, the process just goes to great performance levels. This is the power. It's the power of removing variation. This is the simple step. People think it's not the interesting step. But when you remove variation from your process, you make piles and piles of money, because your machine will behave in a consistently fantastic manner. And now she's just going through some details that she's done in order to optimize this. So what she's basically saying is, I had lots of variables, lots of input variables, condition of the nozzle, the alignment of the driver, etc. And she's kind of showing you the work that she's done here. So you can see, look, they're running the machine with a damaged nozzle. Yeah, so I've got to replace that, but then you've got to put a proper maintenance procedure in place. This is simple stuff, by the way. This is it's not difficult. It's easy things to do. More things on the reset error. This is the toner cap not being removed. Each one, she's going through the details of how she got each one of these and removed the variability. And how do you remove variability? You do a very simple thing. You fix inputs. And that's all she's doing. She's going to fix settings. She doesn't allow technicians to fiddle about with things. She's going to fix maintenance. Yeah, so she's just going to fix the condition of things. She's going to fix the setting of things. And she's just going to hold them in the same place. There is going to be no skill or faffing about by technicians allowed once she's done all of this. Let's keep going. What else we got here? The gear holder. So she's talking about how the gear holder problem, the variables that she worked on and the standard operating procedures that she put in place. Here's a great little technique that I taught them. Do you have an SOP? Are we happy with it? Are we following it? If you cannot tick all three of those, that is an area you need to sort out. Yeah, so in order to have control, you have to have a standard operating procedure, a technique that's agreed. You have to be happy with it. You have to decide that it actually works, and then people actually have to be using them. So she's using that very simple procedure on all of these techniques. And you can see she's taken the gear holder, look, from 8% down to 2%. Other problems that she's got, other variables that she's working on, cleaning out the filter regularly. These are all tiny little things. She's making tiny little controls on the input side of the process in order to remove variability. And as she does this, the process begins to behave. So look, here are all the maintenance type routines that she's put in. Look, to get the maintenance right, filter cleaning, control of the screw fitting on the robot line. What we got? Control of the wear parts, control of the pneumatic leaks, control of the belts on the robot, etc. She's just doing checks after check after check. Yeah, and she's got them all once a week, twice yearly, four times yearly, once a month, etc. And again, what's she doing? She's driving the variability out of this thing. Look at the graphs. Look what she's doing. The variability has been destroyed, yeah, in each one of these. And that's all she's tried to do. What she's not tried to do is hit the target. She's not tried to push this down. She's just said, I want rid of that chaos. And when chaos leaves the process, you make shed loads of money. And look what this has done to the performance graphs as she's dealt with each one of these. So let's just show you, look. I mean, obviously the OEE has gone now from 41%. It's gone up. I think she's going to tell us that that's about 70 at that particular point. So she's taken it from 40 to 70%. That is an amazing transformation in this process just by removing variability. Now look, here's the point, look. This machine was quite happy. It would perform quite well on odd days. But of course, on other odd days, it'd perform bloody awful. So this performance is not impossible. Getting high performance figures for availability wasn't impossible. If you tackle variability, what do? You simply cut the bad performance levels off and you get more and more of the good performance. And that's what she's done here. She's just made the good performance appear more often. That's why variability reduction is so important. She's done the same thing here. This performance here, look, wasn't impossible over here. We were getting it now and again, but we were also getting chaos down here. Removing variability, what's she done? She's guaranteed the good days. Now the quality's been pushed up dramatically. So, you know, she's up here, which to be fair She was never in that area for quality previously. So she has moved this. But what did she do? By moving it up, she hasn't taken all that noise. Look, let me just take that off there. She hasn't taken all this noise and then moved it up here like this and still kept all the noise. What's she done? She removed the variability. What did the machine do? Just consistently went to a great result. And that is what removing variability does. And then what's it done to the total? Well, it's done exactly the same to the total. Now up here, she's now going to go to excellence, because what she's now going to do is she's going to do a design of experiments to wring the last little bit of performance out of this machine, to get the best out of it. But look what she's achieved. Chaos to control. So let's just pop these in. Look, so 71 initially, then it's gone to 75 for January to March this year. She's still dreaming of whether 80% is possible, but she managed to get it there by doing a DOE. Chaos to control. What did chaos to control give her? It gave her a 35% improvement. It gave her a 35% improvement from 41 up to 75. Now that's where all the money is. All the money is in getting control of your processes. The last little bit, which is the excellence up here, which by the way is the fun bit. This is where all the maths is. Yeah, this is where it gets all super technical. Doing a DOE. There's lots of maths and technicality in doing a DOE. But you know what? What did she get? She just got the last. She's going to tell us what the performance went up to, but I think it went into the 80s. But maybe she got the last. Not sure if she got as much as 10%. But she only got the last 10% with the fancy toolkit. The stuff that Six Sigma's famous for. But actually, chaos to control, that's where the money is. The money is in variability. If anybody ever talks to you about variability, listen to them hard, because that is where the money lies in your company. So here's the DOE that she did. Now this is a properly designed experiment. This isn't just any old set of tests. So she's doing 8 tests. She's identified 1, 2, 3 variables that she wants to play about with. This is a properly designed experiment. This isn't just random tests. This is a proper way to do, to learn knowledge on a process. So let's have a look. She's done the analysis, some graphs here showing us how important each one of those variables is, etc. And then what she's done is she's put those settings into the machine, and although she hasn't changed the defect rate too much, the repair rate, look what she did to the cycle time. So she's improved the cycle time dramatically. Here's something else that she's done. She's improved the manual cleaning, look, because she learned that she didn't have to clean the parts quite so vigorously. She's halved the cleaning time, and she's halved the robot cleaning time. So she's not doing anything better necessarily. She's doing the same tasks to the same quality, just faster. That's excellence. Chaos to control made the machine behave correctly initially. It got rid of the problem. It got rid of the pain. What does the DOE do? The DOE delivers excellence. So it's the same performance. It was the same performance, faster. That's often what a DOE does, because the removal of the variation is where the real money is. That's what the real, taking the pain away, fixing the problem, is in controlling variability. So I wanted to show you a case study, the power of variability, but also it's a great case study of chaos, control, Excellent. This was a black belt project, by the way. So this was the second project that she'd done in order to obtain a black belt. And it's just a great example. I haven't given you all the details. I don't need to. The point is there. Remove variability and make shed loads of money.
Well, I hope you found that useful. If you've got any questions about that topic, or indeed anything to do with Six Sigma or Lean for that matter, give me a call and I hope to hear from you soon.